Hello everyone, welcome to Dana's Learning Lab. Today we are going to be going over a topic in organic chemistry called resonance. Resonance is the movement around of electrons in order, preferably, to create a stable molecule. Now, this may not always be possible, but we are going to try our best to move around electrons to see if we can alleviate these charges. Now, we can first notice that oxygen has a negative charge because it has 7 electrons and it only wants 6. So a trick we can use to figure out if it's a positive or a negative charge is to say, how many do we want? We want 6 electrons on the oxygen. And how many do we have? 7. 6 minus 7 is -1, therefore our atom will be negative. For the carbon, it wants 4 electrons. But how many does it have? 1, 2, 3. 4 minus 3 is 1. That will be a positive charge. Now, I'm going to begin by attempting to alleviate this positive charge. What I will do is move this bond over right here. Now, we are going to use our double-headed arrows to signify resonance. When I redraw this molecule, the new bond will be here, the negatively charged oxygen still present, with its 7 electrons, and then we still have this doubly bound oxygen. Now, in moving this bond, I have resulted in a neutral carbon. So this carbon, therefore, is not positive anymore because it has fulfilled its octet. Now, the problem is that I have moved the bond from this carbon right here. Now, this carbon already had 1, 2, 3, and a hydrogen. It has its octet filled, it's neutral. So now the only problem is that we still have this hydrogen, but we have lost an electron. So now the carbon only has 3 electrons and it wants 4. Therefore, since we stole that bond, we are going to label this carbon as positively charged. Now, this is different because we still have a negative and a positive charge, but they're further apart. So now I'm going to see if I can alleviate this negative charge on the oxygen. In fact, we can. What we will do is just move down these electrons, this lone pair, and turn it into a bond. Now, once I have done that, it will look like this. Will be a doubly bound oxygen bond and another doubly bound oxygen. Now, what I have done is alleviated the charge on this oxygen. Now it has its 6 electrons that it wants, 1, 2, 3, 4, 5, and 6. But now we have overloaded this carbon right here. So now that carbon, if you count, has 1, 2, 3, 4, 5 electrons, and it only wants 4. Therefore, it's going to be a negatively charged carbon. And this will remain positively charged. Now, the problem we see here is that a negatively charged carbon is not favorable, and we do not want that in our molecule if possible. Positively charged carbons are fine because typically, if we have a positive and a negative charge, this oxygen can handle the electron density, so it's fine to have that negative charge. But the carbon cannot handle that, so we don't want it to have that negative charge. Now, I noticed that there is really no way to alleviate this positively charged carbon unless I move down this bond again, which will, therefore, I can draw another structure over here with the doubly bound oxygen. Use my arrow to move it over. This doubly bound oxygen. This one is neutral. The carbon now is also having 4 electrons. So now the carbon is also neutral. So now if we have, and this one, I apologize, is still also neutral because it has this hydrogen. So now this is great because we have our neutral oxygen, our neutral carbon, we have this original bond here. now we have both of these carbons with 4 electrons and 2 double bonds. And this, I would say, is the most preferable molecule because we don't have any charges on it. So if on a test, for example, you were told to give the resonance structures, I would give all of these, but then you could circle this one as the most stable. Now, it is possible to go from here, and I'm actually going to draw it over here, to go and keep this double bond, this one, but then move these electrons up to the oxygen, and that would end up in a negatively charged oxygen, which, if you can tell, is basically the exact same molecule as here. They're the same, almost, just flipped the double bond and the negatively charged oxygen on different carbons. So basically, these are all our major resonance structures for this molecule. Sometimes there may only be 2, sometimes there may be 6. So I would recommend drawing as many arrows as you can, going one step at a time. I would not recommend doing more than 2 arrows at a time unless necessary. So this is a more simple one, and I hope this helped you with resonance. If you would like any more topics for me to go over, just leave it down in the comments below. Thank you.